As you settle in for a moment of calm tonight, picture yourself leaving behind the noise of the world and drifting into the quiet embrace of the cosmos. What if, just for a while, you could trade the hum of daily life for the gentle whispers of distant stars and the soft currents of invisible rivers flowing between galaxies? This is where our story begins, not with loud discoveries or dazzling explosions, but in the silent, vast spaces that hold secrets older than time itself. Where are you joining us from, and what time is it there? Let your thoughts float freely as we prepare to explore the hidden threads that weave the universe together, guiding you into a restful journey through wonder and stillness. Now, let us gently turn our gaze outward, toward the boundless expanse that surrounds us. Imagine peering beyond the glow of stars and galaxies into what seems like an endless void. At first glance, this space might appear utterly empty, a blank canvas stretched across the heavens. But look closer, and you'll begin to realize that this so-called emptiness is anything but. Between the galaxies lies an ocean of mystery, vast and quiet, yet teeming with faint whispers of the universe's deepest secrets. The distances here are so immense that they defy our everyday understanding. To give you a sense of scale, consider this. If our solar system were the size of a grain of sand, the nearest galaxy would still be thousands of miles away. And yet, across these incomprehensible stretches, something exists, something ancient and extraordinary, waiting patiently for us to uncover its truths. What might these hidden treasures reveal about the cosmos we call home? Let's take a moment to ponder the possibilities as we drift further into this serene, starlit unknown. As we venture deeper into this cosmic frontier, let us introduce the invisible protagonist of our story, the intergalactic medium, or IM. Though it may sound like something out of a science fiction novel, the IGM is very much a real and vital part of the universe. Picture it as an immense, nearly invisible sea, flowing not with water, but with wisps of gas and specks of particles. This ethereal substance fills the vast voids between galaxies, quietly shaping the cosmos in ways we are only beginning to understand. At its heart, the IGM is composed mostly of hydrogen, the simplest and most abundant element in the universe, alongside helium, which is formed in the fiery hearts of stars. But nestled within this sprawling expanse are also faint traces of heavier elements, carbon, oxygen, and iron, forged in the explosive depths of ancient stars and scattered like stardust across the heavens. Though sparse, these elements tell a story of cosmic recycling, where the remnants of one era become the building blocks of the next. Together, they form a delicate tapestry, weaving through the emptiness and holding clues to the universe's grand design. Now, with this understanding, we can begin to see how the IGM connects the dots of creation itself, bridging the past and future of the cosmos. As we continue, let us explore how this seemingly empty space plays a role far greater than its name might suggest, acting as both a cradle and a conduit for the forces that shape the universe. Now, let us turn our attention to a breathtaking comparison that brings the intergalactic medium into sharper focus. Imagine, if you will, an ocean so vast it stretches beyond the reach of light, yet so delicate that it contains only a few grains of sand in every cubic meter of its expanse. This is the essence of the IGM, a cosmic ocean of particles, thinly spread and almost imperceptible, yet profoundly influential. To truly grasp its nature, consider this. In the emptiest regions of the universe, the IGM holds just a handful of atoms per cubic meter, a density so low it makes Earth's atmosphere seem overwhelmingly thick by comparison. Yet, despite its near invisibility, this ethereal medium wields immense power. It acts as both a repository and a sculptor, carrying whispers of ancient cosmic events, while also guiding the formation of new structures. The IGM's subtle currents, shaped by gravity and energy, ripple across the universe, funneling matter into galaxies and breathing life into the stars. In this way, what appears to be an empty void is in fact a dynamic and essential force, quietly shaping the grand tapestry of the cosmos. As we drift further into this story, let us follow these invisible threads, tracing their influence across the universe's past, present, and future. As we journey deeper into the heart of the cosmos, let us now uncover one of the most remarkable processes shaped by the intergalactic medium, the birth of galaxies. Picture this: within the vast, seemingly empty expanse of the IGM, tiny irregularities begin to emerge. These faint ripples in the fabric of space are the seeds of something extraordinary. Gravity, that relentless cosmic architect, begins its work here. Slowly but surely, it pulls wisps of gas and particles from the IGM toward these slight overdensities, creating regions where matter starts to gather and grow denser. Over millions of years, these pockets of collected material condense further, their gravity growing stronger with every passing moment. In time, these dense regions become the cradles of stars. The gases, primarily hydrogen and helium, compress under their own weight until the pressure and temperature ignite nuclear fusion. This is the spark of light in the dark. An infant star is born. And as more stars form, they cluster together, bound by their mutual gravitational pull, eventually giving rise to the majestic spirals, ellipticals, and irregular galaxies we marvel at today. It's breathtaking to think that these colossal structures, home to billions of stars, owe their existence to the subtle influence of the IGM's scattered atoms. But the story doesn't end there. The intergalactic medium continues to play a vital role, acting as a reservoir that feeds growing galaxies. Streams of gas from the IGM flow inward, replenishing the raw materials needed for new generations of stars. Without this constant cosmic supply line, galaxies would eventually exhaust their fuel and fade into silence. So, while galaxies may appear as self-contained islands of light, they are deeply interconnected with the vast, unseen ocean that surrounds them. With this understanding, we begin to see the universe not as a collection of isolated objects, but as a single, intricate web of creation. And now, let us prepare to explore how this web reveals itself through the tools of modern science. As we shift our gaze to the unseen, we find ourselves facing one of the universe's great puzzles, the challenge of mapping what is hidden in plain sight. The intergalactic medium, though vast and influential, is incredibly difficult to observe directly. Its particles are spread so thinly across the cosmos that their glow is faint, almost imperceptible to even the most advanced instruments. Imagine trying to see the individual threads of a spider's web on a moonless night. It's a task that demands patience, ingenuity, and tools capable of revealing what the eye alone cannot perceive. To uncover the secrets of the IGM, scientists have turned to nature's own lighthouses, quasars. These brilliant beacons, powered by supermassive black holes at the centers of distant galaxies, shine with an intensity that can outshine entire galaxies. As their light travels across billions of light years, it passes through the intergalactic medium, and here's where the magic happens. The gas and particles within the IGM leave behind faint imprints on this light, absorbing specific wavelengths that correspond to the elements present in the medium. By carefully analyzing these absorption patterns, scientists can piece together a map of the IGM's structure, density, and even its temperature. This method, known as quasar light absorption, is like reading the universe's fingerprint. Each quasar offers a unique line of sight, a new path through the cosmic web, revealing how the IGM is distributed across the vastness of space. It's a bit like trying to understand the layout of a sprawling forest by studying the shadows cast on a hazy day, indirect, yet profoundly revealing. With this technique, researchers have uncovered intricate filaments of gas stretching between galaxies, as well as vast voids where the medium is sparse. These observations help paint a clearer picture of the universe's underlying framework, the unseen scaffolding that guides the motion of matter and the evolution of galaxies. And yet, even as we marvel at the ingenuity of these methods, it's important to remember that there is still much to discover. Each new observation brings us closer to understanding the role of the intergalactic medium in shaping the cosmos, but it also raises new questions. What lies within the deepest voids, and how do the filaments interact with the galaxies they connect? As we peer deeper into the invisible, the universe offers us not just answers, but an invitation to wonder. Speaking of connections, we'll soon explore how these filaments act as highways for matter, bridging galaxies across unimaginable distances. Moving forward, let's shine a light on the true role of quasars in unraveling the mysteries of the intergalactic medium. These cosmic powerhouses, fueled by the voracious appetite of supermassive black holes, serve as distant lighthouses scattered across the universe. Their brilliance is so immense that they can illuminate the faintest traces of the otherwise invisible IGM. When their light embarks on its journey across billions of light years, it encounters the sparse atoms and particles of the intergalactic medium along the way. This interaction is subtle yet profoundly informative. As the quasar's light passes through the IGM, specific wavelengths are absorbed, much like how sunlight filters through stained glass, casting distinct colors that reveal the glass's composition. In this case, the absorbed wavelengths correspond to the elements found within the medium, such as hydrogen and helium, as well as traces of heavier elements. By examining these missing pieces in the quasar's spectrum, astronomers can deduce the chemical makeup of the IGM, its temperature, and even its density. It's almost as if the universe is whispering its secrets through these spectral fingerprints. But the insights don't stop there. Quasars also help scientists measure the movement and behavior of the IGM. The light they emit carries subtle shifts caused by the motion of the gas it encounters, akin to the way sound changes pitch as a train approaches and then recedes. This allows researchers to explore how the intergalactic medium flows and interacts with galaxies over time. Together, these observations paint a portrait of a dynamic and ever-evolving cosmos, where even the emptiest regions are alive with activity. With this understanding, we're now ready to delve deeper into the intricate tapestry of filaments and voids that form the cosmic web, connecting galaxies in ways once thought unimaginable. As we venture further into the cosmos, a breathtaking pattern begins to emerge, one that transforms our understanding of the universe's architecture. Picture this: the intergalactic medium isn't just a random scattering of particles. It forms an intricate, organized structure, often referred to as the cosmic web. This isn't merely a poetic description. It's a tangible framework that defines the universe on the grandest scales. Stretching across billions of light years, this cosmic web is a sprawling network of filaments and voids, a celestial tapestry that connects galaxies in ways that defy imagination. These filaments are like glowing threads woven through the darkness of space, composed of gas and dark matter that act as highways for material to flow between galaxies. They trace the paths of gravitational influence, drawing matter toward regions of higher density where galaxies are born and evolve. Between these luminous strands lie vast expanses of emptiness, the voids, which are not entirely empty, but rather sparsely populated with particles. Together, these elements create a dynamic interplay of structure and space, shaping the universe as we know it. What makes this web truly remarkable is how it mirrors patterns found in nature. Think of the veins in a leaf or the branches of a tree. These similarities hint at universal principles at work, connecting the smallest scales to the largest. The filaments themselves are not static. They pulse with energy, channeling gas and influencing the life cycles of galaxies. By studying this web, scientists gain insights into the forces that govern the cosmos, from the pull of gravity to the push of dark energy. And as we piece together this colossal puzzle, we begin to see how everything in the universe is interconnected, a reminder of the delicate balance that sustains the cosmos. With this awe-inspiring framework in mind, we can now turn our attention to the filaments themselves, exploring how they act as conduits for the vital materials that fuel galactic growth and transformation. Let's now shift our focus to the very essence of these glowing threads, the filaments themselves. These are not just passive structures floating in the vastness of space. They are dynamic highways, bustling with movement and energy. Imagine rivers of gas stretching across the universe, carrying vital materials like hydrogen and helium between galaxies. These filaments act as cosmic pipelines, feeding galaxies with the raw ingredients they need to grow, thrive, and create new stars. What's truly fascinating is how these filaments form and function. They originate in regions of slightly higher density in the early universe, where gravity begins to pull surrounding matter toward them. Over billions of years, this process intensifies, creating long, thin strands that connect galaxies like an intricate network of veins. The gas within these filaments isn't static, it flows, swirls, and sometimes even collides, releasing bursts of energy that can heat the surrounding medium. This movement is like the lifeblood of the cosmos, ensuring that galaxies remain vibrant and active. But the role of these filaments goes beyond just transporting material. They also serve as bridges that link galaxies to the larger cosmic ecosystem, allowing them to exchange matter and influence one another across unimaginable distances. In some cases, the gas flowing through these filaments can trigger bursts of star formation when it reaches a galaxy's core. In others, it can be swept away by powerful galactic winds, enriching the intergalactic medium with heavier elements forged in stellar explosions. This exchange is a constant give and take, a cycle that shapes the evolution of galaxies and the universe as a whole. Interestingly, scientists have found ways to map these elusive filaments, even though they are incredibly faint. By observing how light from distant quasars interacts with the gas in these threads, researchers can piece together their structure and composition. This detective work reveals a hidden world of motion and transformation, where the quiet hum of the cosmos tells a story of connection and change. And as we uncover more about these filaments, we begin to see how the universe's grand design is woven together, thread by thread, into a tapestry of wonder and complexity. With this understanding, we can now explore another layer of this intricate system, the role of dark matter, which silently shapes the cosmic web in ways we're only beginning to comprehend. As we venture deeper into the cosmic web, we encounter an unseen force that plays a pivotal role in shaping everything around us. Dark matter, though invisible and intangible, its gravitational pull acts as the unseen architect of the universe, guiding the motion of galaxies and dictating the structure of the intergalactic medium. Imagine dark matter as an invisible scaffold, quietly holding the cosmos together while remaining shrouded in mystery. It doesn't emit, absorb, or reflect light, yet its presence is undeniable, revealed by the way it bends the paths of stars and galaxies. Dark matter's influence extends far beyond what meets the eye. Its immense gravity pulls vast amounts of gas and matter into dense regions, forming the seeds of galaxies and the colossal filaments that connect them. Without dark matter, the universe as we know it might never have taken shape. It acts like an invisible hand, steering the flow of gas within the filaments, determining where galaxies form and how they evolve over billions of years. This makes dark matter not just a passive backdrop, but an active participant in the cosmic drama. What's truly remarkable is how dark matter shapes the very fabric of the intergalactic medium. Its gravity compresses regions of the medium, creating pockets of higher density where gas can cool and condense. These regions then become the birthplaces of stars and entire galaxies, fueled by the raw materials carried along the filaments. At the same time, dark matter's gravitational influence prevents the gas from dispersing too quickly, allowing galaxies to grow steadily over time. In essence, it acts as both a creator and a caretaker, ensuring the universe remains a dynamic and ever-evolving place. To understand the full scope of dark matter's role, picture a vast, hidden ocean beneath the surface of the cosmos. Just as currents in the ocean guide the movement of ships, dark matter's gravitational currents steer the flow of gas and matter across unimaginable distances. This intricate dance between the visible and the invisible is what gives the universe its breathtaking complexity. And while dark matter itself remains elusive, its effects are written across the stars and galaxies, telling a story of silent power and profound influence. With this understanding of dark matter's quiet dominance, we now turn our gaze to another fascinating aspect of the intergalactic medium, its surprisingly energetic side, where shock waves and X-ray emissions reveal the hidden forces at play. As we shift our focus from the quiet, unseen influence of dark matter, we now uncover a more dynamic and energetic side of the intergalactic medium. This is where the universe reveals its fiery temper, showcasing forces that are anything but calm. Some regions of the intergalactic medium emit X-rays, a phenomenon driven by shock waves and violent collisions. These emissions act as cosmic fingerprints, offering us clues about the powerful processes shaping the universe. When gas within the intergalactic medium is compressed or heated to extreme temperatures, it begins to glow in X-rays. This often happens near massive structures, like clusters of galaxies, where gravitational forces are strongest. Picture gas slamming into itself at incredible speeds, creating shock waves that ripple through the medium like sonic booms in space. These shock waves heat the gas to millions of degrees, causing it to emit high-energy radiation that we detect as X-rays. It's like witnessing the universe's own fireworks display, hidden in plain sight, but only visible through the right lenses. The presence of X-rays tells us more than just where these energetic events occur. They also reveal the conditions in those regions, such as temperature and density. For instance, the intensity of the X-ray glow can help scientists estimate how much gas is present and how it's moving. This is crucial for understanding how the intergalactic medium interacts with galaxies and contributes to their growth. It's as though the X-rays are whispering secrets about the medium's most turbulent moments, giving us a front row seat to the drama unfolding across cosmic scales. But why should we care about these distant, high-energy events? Because they paint a picture of a universe in constant motion, far from the static and serene image we might imagine when we look up at the night sky. These X-ray emissions remind us that even in the emptiest regions of space, there's action and energy, a reminder of the universe's restless nature. And as we piece together these clues, we move closer to understanding the intricate balance between chaos and order that defines the cosmos. With this glimpse into the high-energy side of the intergalactic medium, we prepare to explore yet another fascinating phenomenon: how galactic winds carry elements and energy across vast distances, further shaping the universe we see today. As we venture further into the intergalactic expanse, a new chapter of cosmic activity unfolds before us, one driven by forces so powerful they reshape the very fabric of space. Galactic winds, the next piece of this intricate puzzle, sweep through the intergalactic medium like celestial storms, carrying with them the remnants of stellar explosions and the outflows of supermassive black holes. These winds are far from random. They are the universe's way of redistributing matter, spreading elements forged in the hearts of stars across unimaginable distances. Imagine a supernova tearing through its surroundings, unleashing a torrent of energy that propels gas and dust outward at speeds exceeding 1,000,000 miles per hour. This material doesn't just dissipate, it joins the vast currents of the intergalactic medium, carrying with it heavy elements like carbon, oxygen, and iron. These elements, born in the fiery deaths of stars, become the building blocks for new galaxies, new stars, and perhaps even new planets. It's as though the universe is constantly recycling itself, taking the ashes of old systems and using them to ignite new ones. But supernovae aren't the only architects of these winds. At the centers of galaxies lie supermassive black holes, cosmic engines of incredible power. When they consume material, they don't simply swallow everything whole. Instead, they expel vast amounts of gas and energy in the form of jets and winds, blasting material far beyond their host galaxies. This process enriches the intergalactic medium with heavier elements, altering its composition and even influencing how new stars form. Think of these winds as cosmic gardeners, tending to the universe by dispersing nutrients and energy across its vast fields. What makes galactic winds so fascinating is their dual nature. On one hand, they strip galaxies of material, sometimes halting star formation entirely. On the other, they seed the intergalactic medium with the ingredients needed for future generations of stars. This delicate balance between creation and destruction shapes the evolution of galaxies and the medium between them, reminding us that even in destruction, there is potential for renewal. As scientists study these winds, they uncover a deeper understanding of how galaxies grow and evolve over billions of years. For instance, when astronomers observe distant galaxies, they can detect traces of these winds by analyzing the light that passes through the enriched regions of the intergalactic medium. It's like reading the universe's journal, where each gust of wind leaves behind a story written in atoms and energy. And just as these winds shape the cosmos, they also invite us to reflect on the interconnectedness of all things, even on the grandest of scales. With this newfound appreciation for galactic winds and their role in shaping the universe, we now turn our gaze toward a long-standing cosmic mystery, one that has puzzled astronomers for decades. What happened to the missing matter in the universe, and how does the intergalactic medium hold the key to solving this enigma? Now, let's unravel one of the most intriguing puzzles of the cosmos, a mystery that has challenged astronomers for decades. The universe, vast and teeming with wonders, holds within it a secret that lies hidden in plain sight. It's called the missing baryon problem, and it invites us to explore how much of the universe's ordinary matter is quietly tucked away in the intergalactic medium, invisible to the tools we've traditionally relied on. To understand this enigma, we first need to look at what makes up the universe. Scientists have long divided the cosmos into three main components: dark energy, dark matter, and ordinary matter. Ordinary matter, also known as baryonic matter, is the stuff we're most familiar with: stars, planets, gas, and everything we can see or detect. Yet, when astronomers added up all the observable matter in the universe, they found something startling. A significant portion of it, about 30 to 40%, was simply missing. It wasn't hiding in galaxies or floating freely in space, where we could easily find it. So, where did it go? The answer, as it turns out, lies in the intergalactic medium. This vast expanse between galaxies, often dismissed as empty, is actually a reservoir for much of the universe's missing baryonic matter. But why has it remained so elusive? The reason lies in its nature. The gas in the IGM is incredibly diffuse, spread so thinly across immense distances that it doesn't emit or absorb enough light for traditional telescopes to detect. It's like trying to see a whisper in a storm, there, but almost impossible to notice without the right tools. This hidden matter exists in forms that challenge our detection methods. Much of it resides in a state known as the warm-hot intergalactic medium, or WIM for short. The WIM consists of gas heated to millions of degrees, making it emit faint X-rays that are difficult to observe. Other parts of this missing matter are found in cooler filaments, delicate threads of gas stretching across the cosmic web. These filaments are so sparse that their individual atoms are often separated by distances far greater than the width of a football field. But how do scientists even know this matter exists if it's so hard to find? The key lies in indirect methods and clever observations. By studying the universe's overall energy budget, how much matter and energy should exist based on its early conditions, scientists calculated that a significant amount of baryonic matter must be hiding somewhere. They then turned to advanced techniques, such as observing the light from distant quasars. As this light travels through the IGM, it interacts with the gas, leaving subtle imprints on its spectrum. These imprints, like fingerprints on cosmic glass, reveal the presence of otherwise invisible matter. Even with these clues, the search for the missing baryons has been a painstaking process. It wasn't until recent breakthroughs that scientists began to piece together the puzzle. Observations using advanced telescopes, including those that detect faint signals from the Sunyaev-Zeldovich effect, a phenomenon where cosmic microwave background radiation is subtly altered by hot gas, have started to uncover the hidden reservoirs of baryonic matter. These discoveries confirm that much of the universe's ordinary matter resides not in galaxies, but in the vast, quiet spaces between them. This revelation has profound implications for our understanding of the cosmos. It shows us that the universe's story is written not just in its brightest stars and most massive galaxies, but also in the faint whispers of gas drifting through the void. The IGM, once thought to be empty, is actually a treasure trove of information, holding the keys to understanding how the universe evolved and continues to change. As we contemplate this mystery, let's pause to marvel at the ingenuity of both the universe and the scientists who study it. The missing baryon problem is a reminder that even in the emptiest corners of space, there are secrets waiting to be discovered. And with each new revelation, we draw closer to unraveling the intricate tapestry of the cosmos. Ahead, we'll explore how these hidden baryons have been detected and what their discovery means for our understanding of the universe's structure. So stay with us on this cosmic journey. As we venture further into the heart of this cosmic mystery, let's turn our attention to the groundbreaking discoveries that have begun to illuminate the shadows of the intergalactic medium. It's a tale of persistence, innovation, and the power of human curiosity. Over the past few years, astronomers have made significant strides in detecting the elusive baryonic matter hidden within the IGM, using tools and techniques that push the boundaries of what we once thought possible. One of the most remarkable methods involves observing a phenomenon known as the Sunyaev-Zeldovich effect. This might sound complex, but let me simplify it for you. Imagine the universe as a vast, glowing backdrop, filled with the faint afterglow of the Big Bang, known as the cosmic microwave background. Now, picture hot gas in the IGM, subtly altering this glow as light passes through it. This alteration creates a faint but detectable signal, like ripples on the surface of an otherwise calm lake. By studying these ripples, scientists have been able to map regions of the IGM that were once invisible, revealing reservoirs of missing baryons. Another exciting breakthrough has come from X-ray observations. These observatories, designed to detect the faintest emissions from space, have uncovered pockets of gas heated to millions of degrees. This gas, part of the warm-hot intergalactic medium, emits X-rays so faint that they were previously undetectable. But with advancements in technology, astronomers can now identify these emissions, painting a clearer picture of where the universe's missing matter resides. What's truly fascinating is how these discoveries have reshaped our understanding of the cosmos. The IGM, once considered an empty void, is now recognized as a dynamic and essential component of the universe. It acts as a bridge, connecting galaxies and influencing their growth. These hidden baryons, now brought to light, help us piece together the puzzle of how structures in the universe form and evolve over billions of years. And yet, this is only the beginning. Each new observation opens the door to more questions, more mysteries waiting to be unraveled. As we continue to refine our tools and expand our knowledge, the IGM reveals itself not as an empty expanse, but as a rich tapestry woven with threads of gas, energy, and untold stories. Ahead, we'll dive deeper into the temperatures and conditions within the IGM, exploring how these environments shape the universe's grand design. So, let's keep moving forward, one discovery at a time, as the secrets of the cosmos unfold before us. As we shift our gaze to the ever-changing conditions within the intergalactic medium, we uncover a universe alive with contrasts. The IGM is not a uniform sea of particles, but rather a dynamic expanse where temperatures can swing dramatically, shaped by the cosmic forces at play. In some regions, you'll find cool filaments, delicate threads of gas that stretch across the void, their temperatures barely climbing above 10,000 degrees. These cooler zones are often reservoirs of raw material, quietly awaiting their turn to fuel the birth of stars and galaxies. But the story doesn't end there. Elsewhere in the IGM, the temperature skyrockets, reaching millions of degrees in regions heated by the energetic activities of galaxies. Imagine massive supernova exploding with unimaginable force, or supermassive black holes spewing jets of particles at nearly the speed of light. These events inject immense energy into the surrounding gas, creating vast bubbles of hot, ionized plasma. These regions pulse with activity, glowing faintly in X-rays and leaving an indelible mark on the structure of the universe. What makes this temperature variation so captivating is how it shapes the environments we see. Cool filaments act as the universe's supply lines, funneling gas into galaxies where it can condense and ignite new stars. Meanwhile, the hot zones serve as cosmic furnaces, enriching the IGM with heavier elements forged in the hearts of dying stars. This interplay between heat and matter is like a cosmic dance, one that governs how galaxies grow and evolve over time. And yet, these dynamic environments are more than just scientific curiosities. They remind us of the intricate balance that defines the universe, where even the emptiest spaces teem with energy and potential. As we continue our journey, we'll turn our attention to how these elements, forged in the fires of stellar explosions, enrich the IGM and paint a richer picture of cosmic evolution. It's a story of transformation, written in the language of atoms and energy, waiting to be explored. As we venture further into the story of the intergalactic medium, we uncover a transformation that has been unfolding for billions of years. This process, known as chemical evolution, paints a vivid picture of how the universe has grown richer and more complex. At its heart lies a fascinating cycle of creation and dispersal, driven by the life and death of stars. Picture this: within the cores of stars, elements heavier than hydrogen and helium are forged through the intense pressures and temperatures of nuclear fusion. These elements, often called metals in astronomical terms, include carbon, oxygen, and iron building blocks, essential for planets, life, and countless cosmic structures. But stars don't keep these treasures forever. When they reach the end of their lives, they release these materials in spectacular fashion. Supernovae explode with such force that they scatter these elements far into the surrounding IGM, while stellar winds from aging stars gently contribute their share over time. Galaxies themselves play a role in this grand dispersal. In their bustling centers, where stars form and die in rapid succession, powerful outflows of gas are launched into the void. These galactic winds carry the enriched material far beyond the galaxy's borders, seeding the IGM with the remnants of stellar alchemy. Over time, these contributions accumulate, subtly altering the composition of the intergalactic medium. What was once a pristine expanse of primordial gas becomes a tapestry woven with the chemical fingerprints of countless generations of stars. This ongoing enrichment is like a cosmic recipe, where each ingredient adds depth and complexity to the universe. As the IGM absorbs these heavier elements, it transforms into a reservoir of potential, setting the stage for new stars, planets, and perhaps even life itself. It's a reminder that the universe is not static, but ever evolving, shaped by the echoes of stellar lives long past. And as we reflect on this process, we begin to see how the IGM connects the smallest particles to the grandest structures in the cosmos. But the story doesn't stop here. Next, we'll explore another mysterious force at play within the IGM magnetic fields, and how they influence the movement of charged particles across the vastness of space. As we shift our gaze to another captivating layer of the intergalactic medium, we find ourselves drawn into the invisible yet powerful influence of magnetism on a cosmic scale. Magnetic fields, though unseen, are woven into the fabric of the universe, subtly shaping the behavior of charged particles that drift through the vastness of the IGM. These fields are not just random forces, but are born from dynamic processes that stretch back to the early universe and continue to evolve today. To understand their origins, we must first look to the stars and galaxies themselves. Magnetic fields in the IGM are thought to have originated from the tiny, primordial fields present shortly after the Big Bang. Over billions of years, These faint beginnings were amplified by the motion of charged particles in galaxies, particularly through the swirling motions of gas and the explosive outflows from supernova. As galactic winds carried these magnetic fields outward, they infused the IGM with their influence, creating a web of magnetism that spans unimaginable distances. But how do these magnetic fields shape the cosmos? Imagine them as invisible highways, guiding charged particles like electrons and protons as they journey through the void. These fields can alter the paths of cosmic rays, bending their trajectories and steering them across the universe. In some cases, magnetic fields act as shields, protecting certain regions of the IGM from the disruptive forces of high-energy particles. In others, they serve as accelerators, channeling energy and momentum to create dynamic environments where particles can gain incredible speeds. What's even more fascinating is how these fields interact with other cosmic phenomena. For instance, when shock waves from galactic collisions ripple through the IGM, they can amplify magnetic fields, creating regions of heightened activity. These amplified fields, in turn, influence the behavior of gas clouds, sometimes compressing them to the point where new stars can form. It's a delicate interplay of forces, where magnetism plays a quiet but crucial role in shaping the universe's grand design. As we contemplate the reach of these magnetic fields, we begin to see the intergalactic medium in a new light. Far from being a passive void, it is a dynamic arena where forces like magnetism leave their imprint on the smallest particles and the largest structures. And yet, this is only one piece of the puzzle. Ahead, we'll turn our attention to a phenomenon known as the Lyman alpha forest, where the light of distant quasars reveals the intricate fingerprint of hydrogen scattered throughout the IGM. It's a glimpse into how scientists decode the universe's hidden architecture, one spectral line at a time. As we venture further into the mysteries of the intergalactic medium, a new chapter unfolds, one written not in ink, but in the faint glow of ancient light. This is the story of the Lyman alpha forest, a dazzling phenomenon that allows us to map the invisible threads of hydrogen scattered across the cosmos. It's as if the universe itself has left behind a trail of breadcrumbs, waiting for us to piece together its secrets. At the heart of this discovery lies the light from quasars, those brilliant beacons powered by supermassive black holes at the centers of distant galaxies. As their light travels billions of light years to reach us, it passes through the vast expanse of the IGM. Along the way, it encounters clouds of hydrogen gas, each leaving its unique mark on the quasar's spectrum. These marks appear as a series of dips or dark lines, like shadows cast by the hydrogen atoms. Together, they form what astronomers call the Lyman alpha forest, a celestial map etched into the light itself. What makes this phenomenon so remarkable is how it reveals the structure of the IGM in exquisite detail. Each absorption line corresponds to a specific cloud of hydrogen, telling us about its density, temperature, and distance from the quasar. By studying these lines, scientists can trace the filaments of gas that crisscross the universe, connecting galaxies in a vast cosmic web. It's akin to deciphering an intricate code, one that holds clues to the universe's earliest moments and its evolution over time. But why does hydrogen leave such a distinct signature? The answer lies in its simplicity. Hydrogen, the most abundant element in the universe, absorbs light at very specific wavelengths. When a quasar's light encounters hydrogen atoms, their electrons absorb photons at a particular energy level, creating a spectral fingerprint. This fingerprint, repeated countless times across the spectrum, paints a vivid picture of the IGM's composition and behavior. It's as though the universe is whispering its story directly to us, one spectral line at a time. What's even more captivating is how the Lyman alpha forest changes as we peer deeper into the cosmos. Light from more distant quasars reveals the IGM as it was billions of years ago, offering a glimpse into the universe's younger days. In these ancient spectra, we see a denser, more chaotic web of gas, a reflection of the universe's tumultuous infancy. By contrast, the spectra of closer quasars show a more structured and evolved IGM, shaped by the gravitational dance of galaxies and the influence of dark matter. This temporal record allows us to watch the universe grow and mature, much like flipping through the pages of a cosmic photo album. As we marvel at the intricate patterns of the Lyman alpha forest, we begin to appreciate the artistry of the cosmos. It's a reminder that even in the emptiest reaches of space, there are stories waiting to be told, if only we know how to listen. And just as these spectral fingerprints guide us through the IGM, they also lead us to the next step in our journey, the era of reionization, when the universe underwent a transformative phase, igniting the first stars and galaxies and forever altering the fabric of space itself. As we step further back in time, guided by the whispers of the Lyman alpha forest, we find ourselves peering through a cosmic time machine. The Intergalactic Medium, in its quiet vastness, holds clues to the universe's infancy, a time when the cosmos was still finding its rhythm. By studying the IGM, astronomers can uncover secrets of the universe, as it was mere hundreds of millions of years after the Big Bang, long before the first galaxies began to take shape. Picture this: when the universe was born, it was a hot, dense soup of particles, light, and energy. As it expanded, it cooled, allowing protons and electrons to combine and form neutral hydrogen. This marked the beginning of what scientists call the Dark Ages, a time before stars lit up the cosmos, but hidden within the patterns of the IGM, we can still detect echoes of this era. The hydrogen scattered throughout the voids and filaments carries within it the memory of those early conditions, preserved like ancient fossils in the fabric of space. What makes the IGM so remarkable is its ability to serve as both a record and a mirror. Neutral hydrogen, abundant during the Dark Ages, leaves behind a distinct signature when it interacts with light. Through the absorption lines in quasar spectra, we can reconstruct snapshots of the universe's composition and temperature during that distant epoch. These snapshots reveal a cosmos in transition, slowly shifting from neutrality to ionization, a process driven by the birth of the first stars and galaxies. It's like watching the universe wake up from a deep slumber, flickering to life one photon at a time. This transformation wasn't instantaneous. The first stars, often referred to as population 3 stars, were massive and short-lived, their intense ultraviolet radiation carving out bubbles of ionized gas in the surrounding IGM. These bubbles grew and merged, gradually illuminating the universe in what we now call the era of reionization. By mapping the distribution and properties of hydrogen in the IgM, scientists can trace the timeline of this cosmic awakening. It's a testament to how even the emptiest corners of space played a pivotal role in shaping the cosmos we see today. As we piece together these ancient conditions, we begin to appreciate the delicate balance that allowed the universe to evolve. From the simplicity of neutral hydrogen to the complexity of galaxies and stars, the IgM has been both a canvas and a catalyst for cosmic change. And just as it holds the secrets of the early universe, it also points us toward the next chapter of our journey, the epoch of reionization, where the first beacons of light emerge to illuminate the cosmic darkness. As we venture deeper into the cosmic timeline, a new chapter unfolds, one that marks a pivotal shift in the universe's evolution. This is the era of reionization, a transformative period when the first stars and galaxies began to illuminate the cosmos, turning its neutral cloak into the ionized expanse we see today. Imagine a universe still cloaked in darkness, where neutral hydrogen dominated the intergalactic medium. Then, something extraordinary happened. The first stars, massive and radiant, began to shine. Their intense ultraviolet light didn't just brighten their surroundings, it stripped electrons from the hydrogen atoms, turning neutral gas into a hot, ionized plasma. This process, known as reionization, wasn't uniform. It started in small pockets, like tiny sparks flickering to life, and gradually spread across the cosmos. These patches of ionized gas grew larger and merged over time, creating a vast, glowing network that pushed back the shadows of the Dark Ages. What's fascinating about this era is how it reshaped the universe's structure. The first galaxies acted as cosmic lighthouses, their radiation carving out vast bubbles of ionized gas around them. These bubbles expanded, overlapping with others, until the entire intergalactic medium was transformed. Scientists liken this process to a cosmic dawn, where light from the earliest stars and galaxies slowly filled the universe, dispelling the last remnants of its neutral state. Reionization didn't just alter the IgM, it also influenced how galaxies formed and evolved. The ionized gas became hotter and more energetic, making it harder for new galaxies to pull in material and grow. This created a delicate balance. While reionization brought light to the cosmos, it also set limits on how quickly galaxies could emerge. By studying the patterns of ionized and neutral gas in the IgM, astronomers can piece together the timeline of this epoch, gaining insights into the birth of the first luminous structures. This dramatic shift wasn't the work of stars alone. Supermassive black holes, lurking at the hearts of early galaxies, also played a role. These black holes, feeding on surrounding material, unleashed powerful jets of radiation that further heated and ionized the IgM. Together, stars and black holes acted as cosmic engines, driving the transformation of the universe. As we reflect on this era, we begin to see how the universe transitioned from simplicity to complexity. The neutral IgM, once a quiet reservoir of ancient hydrogen, became a dynamic and energetic medium, teeming with the echoes of early cosmic activity. And yet, even as the universe awakened, it left behind traces of its past, hidden within the IgM's intricate web. These traces, waiting to be uncovered, guide us toward our next exploration. How supermassive black holes shape the intergalactic medium, leaving their indelible mark on the cosmos. As we shift our gaze to the mighty forces that sculpt the cosmos, we encounter one of the universe's most enigmatic architects, supermassive black holes. These colossal entities, nestled at the centers of galaxies, wield an extraordinary influence over the intergalactic medium. Their immense gravitational pull isn't their only tool. They also unleash torrents of energy in the form of jets and radiation, transforming the space around them in profound ways. Supermassive black holes can be thought of as cosmic engines, driving change on a grand scale. When they consume material, such as gas and dust, spiraling inward, they don't simply swallow everything whole. Instead, a portion of this material is redirected into powerful jets that shoot out at nearly the speed of light. These jets, composed of high-energy particles and intense radiation, slam into the surrounding intergalactic medium, creating shock waves that ripple through vast regions of space. The impact is staggering. Entire swaths of the IGM are heated to millions of degrees, turning calm reservoirs of gas into seething, energetic plasmas. But the effects don't stop there. These outflows from black holes also stir up the surrounding environment, redistributing matter and energy across immense distances. Picture a mighty river carving through a landscape and reshaping everything in its path. That's what these jets do on a cosmic scale. They push against the filaments of the cosmic web, compressing some regions while clearing out others, and leaving behind a patchwork of hot and cold zones. This process doesn't just alter the temperature of the IGM, it also influences how galaxies form and evolve within it. The heated gas becomes less likely to collapse into new stars, effectively regulating the growth of galaxies and adding another layer of complexity to the cosmic story. One of the most intriguing aspects of supermassive black holes is their dual nature. While they are destructive forces, capable of tearing apart stars and disrupting entire galaxies, they also play a constructive role in the universe's development. By stirring and heating the IGM, they create conditions that encourage the formation of new structures over time. For instance, the shock waves from their jets can compress nearby clouds of gas, triggering bursts of star formation in regions that might otherwise remain quiet. In this way, black holes act as both creators and destroyers, balancing the cosmic scales in ways scientists are only beginning to understand. What makes this topic even more fascinating is how astronomers study these phenomena. Detecting the influence of black holes on the intergalactic medium isn't straightforward, given the vast distances involved. Yet, by observing the X-rays emitted from heated gas and the distortions in the cosmic microwave background caused by these energetic processes, researchers can piece together a clearer picture. These observations reveal just how deeply intertwined black holes are with the fabric of the universe, their actions echoing across billions of light years. As we contemplate the immense power of supermassive black holes, we begin to see them not as isolated oddities, but as integral players in the cosmic drama. Their jets and radiation are like brushstrokes on an infinite canvas, painting the universe with layers of complexity and beauty. And yet, there's still much more to uncover about their role in shaping the cosmos. This brings us to a deeper question. How do these ancient explosions and energetic events leave lasting imprints on the intergalactic medium? Let's explore the echoes of these cosmic phenomena next. Now let's turn our attention to the enduring footprints left behind by some of the universe's most violent outbursts. Ancient cosmic events, such as gamma-ray bursts and supernova, have shaped the intergalactic medium in ways that continue to ripple through time. These cataclysmic phenomena may be fleeting in their brilliance, but their consequences echo across the cosmos for billions of years, subtly sculpting the vast expanse of the IGM. Imagine a single supernova, the explosive death of a massive star, unleashing energy equivalent to the light of an entire galaxy for a brief moment. This tremendous release doesn't just mark the end of one star's life. It sends shockwaves coursing through nearby regions of the intergalactic medium. These shockwaves act like cosmic tsunamis, compressing gas clouds and triggering transformations on a scale almost too vast to comprehend. The heated gas begins to glow faintly in X-rays, a ghostly reminder of the explosion that once occurred, while also influencing how matter clumps together and forms new celestial structures. Gamma-ray bursts, even more energetic and rare, add their own dramatic mark to the IGM. These intense flashes of gamma radiation, thought to arise from the collapse of massive stars or the collision of neutron stars, unleash torrents of energy that can be detected from across the universe. When such an event occurs, its effects are not confined to the host galaxy. The radiation interacts with the surrounding medium, stripping electrons from atoms and leaving behind ionized trails that persist long after the burst fades. These trails serve as markers, helping astronomers piece together the history of the IGM and understand how it has evolved over eons. What makes these echoes so captivating is their dual role in destruction and creation. On one hand, they clear out regions of calm, neutral gas, disrupting the delicate balance needed for star formation. On the other hand, they compress nearby clouds, setting the stage for the birth of new stars and galaxies in previously inactive areas. It's a cosmic dance of chaos and renewal, where destruction paves the way for future creation. These imprints aren't just passive remnants. They actively participate in shaping the universe as we know it today. Over billions of years, the combined effects of countless supernova and gamma-ray bursts have enriched the IGM with heavier elements forged in stellar cores. This process has gradually transformed the pristine gas of the early universe into a complex mixture, containing the raw materials for planets, stars, and even life itself. In a very real sense, the echoes of these ancient explosions are part of our own cosmic heritage. Understanding these phenomena requires us to think across vast timescales, connecting the dots between events that occurred billions of years ago and the state of the universe today. By studying the subtle fingerprints left behind in the IGM, scientists can trace the evolution of cosmic structures and uncover clues about the conditions that existed shortly after the universe began. It's a humbling reminder that even the quietest corners of space bear the scars and stories of unimaginable events. As we move forward, let's explore how all these forces come together in a grand symphony of cosmic interactions, orchestrating the growth and transformation of the universe. As we shift our gaze to the intricate ballet of forces that govern the intergalactic medium, it becomes clear that this vast expanse is not just a passive backdrop, but a dynamic stage where the universe's grandest performance unfolds. Picture gravity as the steady hand of a conductor, gently yet irresistibly pulling threads of gas and matter into intricate patterns. It gathers wisps of primordial hydrogen and helium, drawing them into denser knots where galaxies begin to take shape. These regions, once scattered and diffuse, grow more defined over time, guided by the unseen hand of this cosmic maestro. But gravity isn't the only player in this symphony. Pressure pushes back, a counterforce that resists collapse and maintains the delicate equilibrium needed for structure to form. Imagine clouds of gas compressed by gravitational forces, their particles pressing against one another like notes, straining to escape a tightly wound chord. This tension gives rise to vibrant bursts of energy, releasing light and heat that ripple outward through the IGM. It's here that radiation joins the ensemble, acting as both a sculptor and a messenger. High-energy photons from distant quasars or newborn stars sweep through the medium, carving pathways and leaving behind trails of ionized particles that glow faintly in their wake. Together, these forces create an interplay so rich and complex, it rivals any masterpiece. Gravity pulls, pressure resists, and radiation illuminates, each contributing its unique voice to a composition that has been playing since the dawn of the cosmos. And just as a symphony evolves with every movement, so too does the universe transform under the guidance of these celestial instruments. Regions once cold and dark become alive with activity, birthing stars and galaxies that add new layers of complexity to the cosmic score. What's truly remarkable is how this symphony connects the smallest scales to the largest. The same principles governing the collapse of a single gas cloud echo across millions of light years, shaping the filaments and voids of the cosmic web. This duality reminds us that the universe operates on a continuum, where the actions of individual particles influence the destiny of entire galaxies. Every star that ignites, every shock wave that ripples through the IGM adds another note to this ever-evolving melody, ensuring no part of the cosmos exists in isolation. As we marvel at this intricate harmony, it becomes easier to see the universe not as a static expanse, but as a living entity, growing and changing with each passing eon. And now, with this understanding of the forces at play, we're ready to explore how scientists are tuning into the universe's subtle signals, using tools like radio waves and gravitational waves to uncover even more about the intergalactic medium and its role in the grand design. Just as a new movement begins in a symphony, let's turn our attention to how scientists are learning to listen to the universe in ways that reveal even more about the intergalactic medium. The cosmos, it turns out, is not silent. It hums with energy, carrying whispers from the distant past, and modern technology is allowing us to tune in like never before. Through radio waves and gravitational waves, researchers are uncovering clues that help piece together the story of the IGM and its role in shaping the universe. Radio waves, invisible to the naked eye, have become one of the most valuable tools in astronomy. These waves travel vast distances, passing through the intergalactic medium and carrying imprints of the environments they encounter. Imagine them as cosmic echoes, bouncing back tales of ancient galaxies, primordial gas clouds, and the faint traces of matter that fill the voids between stars. By using powerful radio telescopes, scientists can detect these faint signals, translating them into maps that reveal the hidden structures of the universe. It's as if we're hearing the universe's heartbeat, a gentle pulse that tells us how the IGM connects everything in the cosmos. But radio waves are only part of the story. Gravitational waves, ripples in the fabric of space-time itself, offer another way to study the universe. These waves are created by cataclysmic events, like the collision of black holes or neutron stars, and they travel across billions of light years, carrying with them information about their origins. When these waves pass through the intergalactic medium, they interact with the gas and particles, subtly altering their properties. By carefully analyzing these changes, scientists can gain insights into the density, temperature, and even the magnetic fields of the IGM. In a sense, we're not just hearing the universe, we're feeling its vibrations, like the strings of an instrument resonating through the void. What makes these methods so fascinating is how they complement each other. While radio waves provide a broad overview, painting a picture of large-scale structures, gravitational waves offer precision, pinpointing exact events and their effects. Together, they create a richer, more nuanced understanding of the intergalactic medium. It's akin to listening to a piece of music with both your ears and your fingertips, feeling the vibrations while hearing the melody. This dual approach allows scientists to probe deeper than ever before, revealing the hidden dynamics of the universe. As we reflect on these new ways of listening to the cosmos, it becomes clear that the intergalactic medium is not just a passive element of the universe, but a vibrant participant in its ongoing evolution. These waves remind us that even the quietest, most distant corners of space are full of activity, waiting to be uncovered. With this in mind, we're ready to journey even further into the mysteries of the IGM, imagining what it might feel like to drift among its faint glimmers and gentle hums, surrounded by the timeless beauty of the universe. As we gently shift our gaze from the tools that uncover the universe's secrets, let us now step into the heart of the intergalactic medium itself. Picture this: you are weightless, adrift in an ocean of cosmic stillness, carried by the faint currents of particles older than time. Around you, the intergalactic medium stretches endlessly, a vast and tranquil expanse, dotted with the faint glimmers of distant galaxies. Their light, though dim, feels like whispers from across the ages, each one a reminder of the universe's quiet persistence. The sensations here are subtle, almost imperceptible, yet deeply profound. You feel the gentle hum of cosmic energy, a vibration so faint it seems to ripple through your very being. It's not sound in the way we know it, but a resonance of existence itself, as if the universe is breathing and you are part of its rhythm. The IGM is not empty, you realize. It is alive in its own way, a tapestry woven from the faintest traces of matter and the echoes of ancient events. Every atom, every particle, carries a story, a fragment of the cosmos's history waiting to be felt. Imagine drifting closer to one of those faint glimmers. It begins as a soft glow on the horizon of your vision, but as you approach, it reveals itself to be an entire galaxy, teeming with stars and worlds beyond comprehension. Yet, from this distance, it feels serene, almost dreamlike. You notice how the galaxy's light bends and shifts as it passes through the thin veil of the intergalactic medium, scattering like sunlight through a mist. This is the universe's way of reminding you that even the most distant and unreachable wonders are connected to the space you now inhabit. As you float here, suspended between the galaxies, you begin to sense the enormity of the cosmos in a deeply personal way. It is not overwhelming but comforting, like being cradled by something far greater than yourself. The IGM becomes a place of reflection, where the boundaries between self and universe blur. Every breath you take feels synchronized with the pulse of the cosmos, every thought a ripple in the fabric of space. This is what it means to dream among the stars, not as an observer, but as a participant in the grand, unfolding story of the universe. This dreamlike journey is more than just an escape. It is an invitation to see the universe in a new light. And as we let these sensations wash over us, we prepare to turn our gaze inward, to explore the poetry hidden within the vastness of empty space. Now, let us pause for a moment and turn our thoughts to the spaces themselves, the quiet, the still, the seemingly empty. In this vastness, there is a profound kind of beauty, one that invites us not to fill the silence, but to embrace it. The emptiness of the intergalactic medium is not a void in the traditional sense. It is not barren or lifeless. Instead, it is a canvas, vast and unmarked, waiting for the universe to paint its story across it. It is a reminder that even in what appears to be nothingness, there is potential for creation, for connection, for wonder. Think about how we often fear empty spaces in our own lives. We rush to fill quiet moments with noise, with distractions, as if silence were something to be avoided. But here, in the depths of the cosmos, the emptiness speaks. It whispers of patience, of time stretching far beyond human comprehension. It tells us that there is value in simply being, in existing without the need to constantly do or achieve. The intergalactic medium teaches us this lesson in its own quiet way, offering solace to those who are willing to listen. Imagine for a moment that you are not just floating through this space, but becoming a part of it. The emptiness around you is not indifferent. It is welcoming. It holds you gently, like a calm sea cradling a small boat. There is no pressure here, no urgency. You are free to simply exist, to let your thoughts drift as effortlessly as the particles that make up this cosmic ocean. In this stillness, you may find something unexpected, peace. A deep, resonant peace that comes from aligning yourself with the rhythms of the universe, rather than struggling against them. This beauty of emptiness is not just a concept, it is a feeling. It is the warmth that comes from realizing you are part of something much larger than yourself, yet also knowing that your presence matters. Every breath you take, every thought you have, adds to the tapestry of existence, just as every particle in the intergalactic medium plays its role in shaping the cosmos. There is no hierarchy here, no sense of insignificance. Each element, no matter how small, has its place. As you allow this realization to settle into your mind, you begin to see the universe in a new way. The vastness is no longer intimidating, it is comforting. The emptiness is no longer lonely, it is full of possibility. And as you drift further into this state of calm reflection, you may feel your worries begin to dissolve, carried away by the gentle currents of cosmic energy. This is the gift of the intergalactic medium, a reminder that even in the quietest, most remote corners of existence, there is beauty, there is meaning, and there is peace. And with this understanding, we prepare to explore the timeless nature of the intergalactic medium, where eternity itself becomes a companion on this journey through the stars. As we venture deeper into the heart of the intergalactic medium, we find ourselves brushing against the edges of eternity itself. This is a place where time stretches and softens, losing its rigid boundaries. Here, in this vast expanse, the concept of lifespan becomes almost insignificant. The intergalactic medium exists on scales that dwarf our fleeting human moments. It has witnessed the rise and fall of stars, the birth and death of galaxies, and the quiet persistence of cosmic forces that shape existence itself. Think of it this way: while our lives are measured in decades, the IGM operates on timelines that span billions of years. Yet, within this immense timeline, every second, every flicker of movement carries meaning. The particles drifting through this medium have been part of the universe's story for longer than we can comprehend. They are ancient travelers, carrying whispers of events that occurred long before humanity ever gazed at the stars. These whispers are not loud or urgent. They do not demand attention, but they are there, patient and enduring, waiting for those who are willing to listen. What does it mean to exist within something so timeless? For us, as short-lived beings, it can be both humbling and uplifting. On one hand, it reminds us of our smallness, how brief our moment is in the grand sweep of cosmic history. But on the other hand, it also reminds us of our connection to this greater whole. Just as the intergalactic medium holds the remnants of stars that burned out eons ago, it also holds the potential for new beginnings, for worlds yet to form and stories yet to unfold. Consider how this perspective might change the way we view our own lives. If the IGM can endure across billions of years without rushing or faltering, perhaps we too can learn to embrace the passage of time with a little more grace. We often measure our days by accomplishments, by ticking off tasks and chasing goals. But what if we allowed ourselves to simply be, much like the IGM itself? What if we found beauty in the slow, steady rhythm of existence, rather than constantly striving for more? The timeless nature of the intergalactic medium serves as a mirror, reflecting back our own place in the universe's grand design. It shows us that life is not just about individual moments, but about the connections between them, the way everything flows together, like threads in a cosmic web. And as we sit with this thought, we begin to understand that the IGM is not merely a passive backdrop to the drama of the cosmos. It is an active participant, shaping and being shaped by the forces around it over unimaginable stretches of time. This realization gently carries us forward, inviting us to imagine how the universe's quietest spaces continue to influence its most dynamic events. It sets the stage for understanding how even the faintest glimmers of light from distant galaxies weave their way through this eternal expanse, connecting us to the farthest reaches of the cosmos. As we ease into this next chapter of our cosmic journey, let the stillness of the intergalactic medium envelop you like a soft, endless night. Picture yourself adrift in this infinite darkness, surrounded by landscapes that defy the limits of imagination. Ahead lies a realm where glowing filaments stretch across the void, their faint luminescence painting the universe with threads of gold and silver. These are not mere streaks of light. They are rivers of matter, ancient pathways that connect galaxies in an intricate celestial dance. Imagine floating through these serene vistas, where time feels irrelevant and the vastness around you hums with quiet energy. The filaments pulse gently, as if alive, carrying traces of the universe's earliest moments within their delicate glow. Between them lie tranquil voids, immense expanses of near nothingness that hold their own mysteries. Far from being empty, these voids whisper secrets of the cosmos, hiding faint traces of gas and particles that science is only beginning to uncover. Together, the filaments and voids create a breathtaking mosaic, a cosmic web so vast it defies comprehension. What makes these glowing threads even more remarkable is how they shape the universe we know. They act as highways for material, guiding streams of gas and dust into regions dense enough to spark the birth of stars and galaxies. Without these shimmering connectors, the universe as we see it might never have taken form. Yet here, in this quiet expanse, they exist almost unnoticed, their importance hidden beneath their understated beauty. Now, take a moment to let your mind wander among these celestial wonders. Feel the calm of endless space, where there are no deadlines, no pressures, just the steady rhythm of cosmic evolution. The glow of distant galaxies casts faint reflections on these filaments, like fireflies illuminating the edges of an eternal forest. Here, in this realm of infinite darkness, every movement feels deliberate, every shift deliberate yet unhurried. And as we continue forward, let this vision of the intergalactic medium remind us of the harmony between chaos and calm. While the filaments tell stories of creation and connection, the voids speak of rest and potential. Together, they form a balance, a reminder that even in the quietest corners of the universe, there is always motion, always life waiting to emerge. This balance sets the stage for understanding the universe's quiet heart, where stillness reigns supreme amidst the grand symphony of existence. As we gently pivot from the grand tapestry of filaments and voids, let us now turn our attention to the very essence of serenity within the cosmos. This is the universe's quiet heart, a place where stillness reigns and whispers of calm replace the thunderous activity found elsewhere. Here, in the depths of the intergalactic medium, there exists a stark contrast to the bustling centers of galaxies, where stars are born in fiery bursts and black holes churn with relentless energy. Instead, picture an expanse where time itself seems to pause, where the absence of chaos invites a profound sense of peace. Imagine standing at the edge of this tranquil realm, far removed from the swirling storms of galactic cores. In these regions, there are no explosive supernovae lighting up the sky, no jets of particles racing outward from supermassive black holes. Instead, the environment is one of gentle equilibrium, where even the faint glow of distant galaxies feels like a comforting presence rather than an intrusion. It's as though the universe has carved out this space specifically for rest, a sanctuary suspended between the vibrant hubs of activity that define its more energetic zones. This stillness, however, is not emptiness. Even in its calm, the intergalactic medium holds an understated vitality. Its sparse atoms drift lazily, their movements almost imperceptible, yet they carry the weight of billions of years of cosmic history. These particles are remnants of the universe's earliest days, echoes of processes that shaped everything we see today. They remind us that even in stillness, there is movement, slow, deliberate, and timeless. For those who find themselves overwhelmed by the noise and pace of daily life, this quiet heart of the universe offers a powerful lesson. It teaches us that calm does not mean stagnation, that stillness can coexist with purpose. Just as the intergalactic medium nurtures the potential for future stars and galaxies, so too can moments of quiet reflection nurture our own growth and creativity. It's a reminder that sometimes the most profound transformations begin in silence. Now, as we linger in this peaceful corner of the cosmos, take a deep breath and let the stillness wash over you. Feel the weight of the universe's grandeur, not as a force that overwhelms, but as a presence that comforts. Here, amidst the faint glow of filaments and the vastness of voids, lies a haven of calm, a place where the universe itself seems to breathe alongside you. And as we prepare to venture further into this story, keep this quiet heart close, for it will guide us through the symphony of forces that shape the cosmos. Ahead, we'll explore how even the subtlest movements within this stillness hold the keys to understanding the universe's greatest mysteries. As our journey through the quiet heart of the universe begins to draw to a close, let us turn our gaze outward once more, toward the infinite expanse that stretches beyond our reach. Picture this: countless stars scattered like whispers across the intergalactic medium, their light so faint it eludes even the most sensitive instruments, yet steadfast in their eternal glow. These distant suns, billions upon billions of them, exist in a realm untouched by human eyes, their brilliance hidden not by absence, but by the sheer vastness of space itself. Though we cannot see them, these stars are far from silent. They tell stories of cosmic evolution, of ancient galaxies that once burned brightly before fading into the gentle hum of the universe. Their light, traveling for millions or even billions of years, carries fragments of history, snapshots of moments long past, preserved in beams that may never touch our world. It's humbling to think that some of these stars may have already lived out their entire lives, their light still journeying across the void long after they've extinguished. In a way, these unseen stars remind us of the beauty of mystery. They challenge us to imagine what lies beyond the limits of our perception, to find wonder in the unseen and the unknown. Each one is a testament to the universe's boundless creativity, a spark of possibility in an ever-expanding canvas. And while their light may never reach us, their existence shapes the fabric of the cosmos, influencing the delicate balance of forces that govern everything we know. As you drift deeper into this sleep story, allow yourself to feel the presence of these stars, their quiet persistence, a comforting reminder of resilience and endurance. Though they may be beyond our reach, their light connects us to something greater than ourselves, a shared legacy written in the language of physics and time. And so, as we honor these unseen sentinels of the cosmos, let their enduring glow guide you into a restful state, where dreams carry you to faraway galaxies and the spaces between. Ahead, we'll conclude our exploration by reflecting on the timeless nature of the intergalactic medium, a final meditation on its role as both a cradle and a keeper of the universe's deepest secrets. As we gently bring this cosmic voyage to its close, let us take a moment to linger in the stillness that surrounds us, the kind of stillness only the universe can offer. This vast expanse, threaded with invisible filaments and glowing whispers of distant stars, holds a beauty that is both humbling and deeply comforting. It is here, in the spaces between, that the universe writes its most enduring stories of creation, transformation, and the quiet persistence of light. You see, the intergalactic medium is not just a passive backdrop to the drama of galaxies. It is an active participant in the grand symphony of existence. Its diffused threads weave together the past and present, carrying within them the echoes of ancient explosions and the seeds of future worlds. It is a reminder that even in what appears to be emptiness, life and movement endure. The universe, in all its complexity, invites us to find peace in its mysteries, to let go of the need for answers and instead embrace the wonder of the unknown. And so, as you settle into this moment of calm, allow yourself to be carried by the soft currents of imagination. Let the intergalactic medium become a bridge between the world you know and the dreams that await you. Picture yourself floating through its tranquil void, surrounded by the faint glimmers of galaxies yet unseen, their light a gentle hum against the silence. Feel the pull of faraway places, where stars are born and stories unfold in ways we may never fully understand. Let this be your invitation to dream boldly, to let your mind wander beyond the familiar and into realms untouched by maps or time. For in those spaces, you may find not just distant galaxies, but pieces of yourself reflected in the infinite possibilities of the cosmos. As we conclude this journey, remember that the universe is not something far removed from us. It is a part of us, written into our very essence. So tonight, as you drift into sleep, carry with you the quiet glow of discovery and the endless promise of what lies beyond. Thank you for joining me on this exploration of the intergalactic medium. If you enjoyed this sleep story, please consider subscribing to the channel, liking this video, and hitting the notification bell so you never miss another journey through the stars. Until next time, sleep well, and may your dreams take you to places even the universe has yet to imagine. you.